Good afternoon, everyone. Half hour in the break, the coffee is kicking in. I can promise you we're going to have some fun. My name is Stijn. I am technical evangelist based out of Barcelona. I'm passionate about many things, but I love to talk about Docker, Kubernetes, cloud-native technologies. In this session, we're going to talk about Kubernetes. And we all understand the benefits that Kubernetes brings us. There is the flexibility and the portability. Kubernetes allows us to easily schedule our workloads across our cluster, wherever we have capacity available. It allows us to easily pick up a workload and move it to another part of our cluster. A second benefit is around efficiency. Kubernetes allows us to schedule multiple workloads on one virtual machine, one physical server. And then finally, there are the benefits of scalability. Kubernetes helps us to scale our environment if the number of users increases, if the number of API calls to our backend increases, to be able to handle the load, to be able to guarantee perfect performance. Now, scalability is exciting, but it's also very scary. You know what else is scary? Jumping out of an airplane. It's not only scary, it's also stupid. This is me jumping out of an airplane this summer in Australia. It's exciting, it's scary, and if you want to do it with confidence, you need the right tools. For starters, a parachute. In my case, also an instructor. And the same is true for Kubernetes. Kubernetes is exciting, but it can be scary. If you want to do it with confidence, you need the right tools. So that's what we're going to talk about. How can you have confidence in the Kubernetes environment that you're deploying and running at scale? There are 3 simple steps that you need to do to get observability in your platform. I will talk about those in a minute. But first, there are many flying parts in a Kubernetes environment. How do you understand what's going on? Think about the following. What is the capacity we have left in our cluster? How much headroom do we have for our memory consumption? If storage is failing, which pods, which containers, which workloads are impacted? If there is an issue and one of our containers is impacted, how does this impact my end user? There are many flying parts, and we want to get visibility into each layer of our Kubernetes stack. So how do we do this? 3 easy steps. The first step within the New Relic platform is really a preparation step. So what we do is we deploy a service called kubestate-metrics. And kubestate-metrics gives us information about all the objects in my Kubernetes cluster. We gather that information to help you understand what's happening. The way we do this is by using the New Relic Kubernetes integration. That's the second step here. So we're going to deploy the New Relic Kubernetes integration as a daemon set. In a Kubernetes environment, a daemon set means that the agent is automatically provisioned on each node of the cluster. This makes it really easy to manage this. If you grow your cluster, the New Relic agent will be automatically provisioned on that node. And then the third step for us is we want to be able to collect our log files. So we saw a lot of great things about logging today. So what we want to do is we want to set up, for example, FluentBit in our Kubernetes cluster to stream the log files to the platform. Let's have a look. So if we can switch to my laptop now, please. So what I have here today is I have an EKS cluster. So EKS is a Kubernetes environment that is managed by AWS. At this point, I have a couple of nodes in this cluster. So I have about 5 nodes in the cluster. There are a bunch of things running actually in this cluster already. I have deployed a simple game to the cluster. And this is what you can see here. We have a front end running, so this is serving the user interface of our game. We have an authentication service running and an analytics service. We can already see that something interesting is going on here. So I'll come back to this in a minute. I've already deployed the new Relic agent. So we have 5 nodes in the cluster, so it makes sense. We also have 5 New Relic infrastructure agents, 5 pods running in our cluster. We can also see Fluent Bit here. So this is the part that is responsible for sending the log files to the New Relic platform. So great. We have a bunch of stuff running in our cluster. Data is being sent to the New Relic platform. Let's have a look at New Relic 1. So we've seen the Cluster Explorer, the Kubernetes Cluster Explorer, a few times today. I want to explain in a bit more detail what exactly is happening here. So this represents our Kubernetes cluster, this view. Each slice of the pie represents 1 node in the cluster. So as I showed earlier, we have 5 nodes, so I can see that we have 5 slices in our pie here. If I hover over any of these slices, I get information about the host and the resource consumption. We can also see that we have many pods running in this cluster. So each hexagon here represents a pod running in my environment. Now, let me quickly go back to my terminal. We have something running here in our Cluster Explorer. We have a horizontal pod autoscaler running. And a horizontal pod autoscaler is responsible for scaling up our environment if the load on the environment increases. And what you can see here in this case is that we've set a target. And the target in this case relies on our CPU consumption. So if the CPU consumption increases, the autoscaler will automatically scale up our environment. Now, what we want to do here is I want to put a watch on this. I want to keep an eye on this and see what's happening during the rest of the talk. So let's have a look. Right now, we can see that we have 3 pods running. And let's see later if this scales up. So going back to our Cluster Explorer, we see many different pods in this environment. In the very center, I can also see that there is 1 pod running. What does this mean? We're showing the pods that are in the pending state. So this means that this pod was not scheduled onto the cluster. Now, if I want to get more details, I can click on any of these pods. So let's do that. Let's have a look. I can see that in this case, the pod is in the pending state. And we can see the reason why it is still in the pending state. I see an image pull backoff message. And if I look a little bit closer, I can actually see that we provided a wrong image tag. So Kubernetes is unable to retrieve this Docker image from our repository, so it's unable to schedule this Docker image and this pod to the cluster. We can actually also look at the events that we see happening. And in this case, Kubernetes is trying periodically to schedule this pod on the cluster. So in the meantime, it has already tried 47,000 times to schedule on the cluster. But I haven't updated my Docker image, so it's still failing. So these Kubernetes events give a lot more context to what's happening. When you start a new deployment, when you automatically scale, you will see these events popping up in the interface. OK. Now, to be fair, this is a pretty boring cluster, right? There isn't that much happening. I want some action, and I need your help. Pull out your mobile phones and scan this QR code or enter the bit.ly link. We're going to play a game. And I'm challenging you to try and break my cluster. If you follow the link, if you open the game, you will see a very simple button you can push. Every time you push the button, it will send a request to my EKS cluster. So go ahead and hammer on that button. Please show your phone if you have the game up and running. I want to make sure we have a good load. All right, looking good. Keep pushing, keep pushing. I want to make sure we got some load. And I hope the Wi-Fi allows you to do it. So let's go back to our horizontal pod autoscaler. All right, we're kicking in. Keep hammering, please, keep hammering. So we can already see that the load on our environment is increasing. Our autoscaler has increased the number of pods in our environment from 3 to 4. I want to see more. This is not enough, and I'll make it a bit easier for you. So currently, you're able to push the button once every second. I'll put this a little bit lower. In a minute, you should be able to push every 100 milliseconds. So come on, go for it, and help me increase the load on our environment. So let's go back to our Cluster Explorer. And let's see if we can see something happening. So there are a lot of pods running in my cluster. We had our agent, we had a few services. So what I want to do right now is I want to zoom in and see what's happening with our front-end service. And I already can see a few interesting things happening here. It seems one of my pods is in an alerting state. It's being marked as red. Something is going on. I'll have a look at this in a minute. But what I really want to do right now is I want to zoom into something. I want to zoom into the front-end deployment. I want to see what's happening. And if I zoom in, I can see, yes, we currently have 4 pods running, while originally we started with 3 pods. Let's dig in a little bit more deeper. So what I can do is I can click on any of these pods here, and I can get more details. So what we see right now is more context about this container, about this pod. So I can track the resource consumption. And as you can see here, resource consumption is going up. But what is really key here is that I'm tracking the application performance of my app running in this container. So I can see that my transaction time is going up, my throughput is going up, because you're all hammering my application. Keep going for it, keep going for it. I want to challenge you to crash my cluster. Now, another thing very interestingly we see here is that there is a high error rate. What's going on? So let's have a closer look. I want to pull up some log files here. And let's have a look at what's happening. I can see some errors here. So this log file is coming from my front-end containers. And I can see that apparently we have an exception, an error exception. I failed to parse user agent Android, it seems. What we can do is we can also zoom in and look for more errors like this. We've seen the logging experience before. And it seems that all of the exceptions are similar. It seems that it's all for Android devices. Who of you has seen an error on their phone? Has anyone seen an error? What device do you have? Android phone. Bingo. This is really the power of correlating the log files with our APM data all within the Kubernetes Cluster Explorer. It makes it easy for troubleshooting. I didn't have to switch tools. I was able to show what is going on right within the new Relic 1 platform. Great. OK, so this was cool and fun. Can we please switch back to the slides? So this was cool and fun. We were playing a game. We were able to show how we can understand what's going on in our Kubernetes Cluster Explorer by correlating application performance with the logging data in the right context, right where we need it. But Kubernetes isn't only fun, it's serious business. It's serious business for a lot of our customers. I'm very excited that we have one of our customers here today, USA Today. Please help me welcome Kyle Weaver, Senior Site Reliability Engineer at USA Today. Kyle, there was a cool song to introduce you, so let's wait for that. It's great to have you here, Kyle. We've been talking about running Kubernetes at scale. We had some fun with running a game. I think everyone knows what USA Today is, but please, can you tell us a little bit more about USA Today and your role?
Yeah, absolutely. So first, thanks, Tim, for having me. I'm excited to be here. So USA Today is owned and operated by Gannett, a local to national media and marketing solutions company. We're also the largest local media company in the nation. Our brands include USA Today, as well as over 100 other local media organizations across 34 states. So my role at USA Today is a senior site reliability engineer. And the SRE team at USA Today owns and monitors over 200 services across our East and West regions. Now this includes our internal automation tooling, as well as our desktop web applications.
200 services, that's a nice scale. But how do you think about scalability? Are there different types of scalability, different challenges you think about?
Yeah, so when it comes to scaling for us, there's three main scaling events that we have to consider. So first is our daily users. As our users are logging on, our transactions start to pick up, and as they're logging off, they start to go back down. Now this is a pretty gradual change over the course of the day, and we can predict it fairly well based off of our historical data. The next type of event are those major planned events, and one of the biggest ones for us is elections. So for elections, we know exactly when they're going to be, and we're able to perform some additional load testing prior to the event. And we normally have a war room the night of to monitor our systems and ensure they're performing as we expect. Now, the scariest scaling event to us, or the most unpredictable one, is breaking news. So breaking news is another major event, but it's unplanned, and our journalists are covering this in real time. So since it's unpredictable, we have to ensure our systems can scale on demand, and that's where we rely on New Relic to help paint the picture as to what's going on.
So speaking of this breaking news, recently there was a very tragic event, right? The Notre Dame in Paris was on fire. This was global news. It impacted a lot of people. How did it impact USA Today?
Yeah, so this was a tragic event with global reach. And our journalists at the peak of the event were updating articles at least once a minute over a 3-hour duration. And of course, we saw a huge spike in traffic to usatoday.com.
Yeah. You know, how do you handle this? From a calm day, people are reading the news during breakfast, maybe during office hours, to such an impactful event where everyone wants to get real-time updates. How do you handle this?
Yeah, so we've architected a solution leveraging Fastly as our CDN and Google Kubernetes engine to manage these breaking news events. So what happens is when our journalists go and update an article, our content management system will then bust the cache on our CDN. Of course, this sends a lot more traffic back to our origin servers. And as we saw in your demo with the HPAs, that traffic will then start to cause our pods to scale horizontally and handle that additional load.
Okay, cool. So you're also using horizontal pod autoscalers, HPAs, but at what scale do you typically operate?
Yeah, so from a daily perspective, we typically peak out at around 25 pods in our East and West region for USA Today. Now, going back to the Notre Dame event, this is actually the first time we hit our maximum limit on our HPA configuration. So after we got done tweaking it and tuning it to handle the actual scale we were dealing with, we were running 110 pods in each region. So almost 5 times our daily peak pods.
Impressive and scary at the same time.
Yes.
How were you notified from this event, and how did you kind of go with it?
Yeah, so at the time, we actually didn't have any alerting around hitting that max HPA limit. Instead, we were alerted on an increase in our origin latency. So what this means is, for those requests that go back to our origin servers, the page load time may have been a little bit higher than what we would typically want for our users. So that then triggered our alert for our on-call team members. And what we do from there is go and check out a New Relic dashboard to figure out what's going on.
OK, so it would be great if we could talk a bit about those dashboards. Shall we pull up a dashboard and talk about it?
Let's check it out. All right. So starting in the top left is our origin latency. And of course, as we already described, that's what alerted our engineers. And that was starting to creep up over time as the Notre Dame event was starting to pick up. In the top center are the number of pods that were running in each region. And at the time, this would have actually been pegged at the maximum, so 80 pods in each region. But we didn't have any thresholds defined or any alerting around it, so it didn't really mean too much for us at the time. And in the top right are our transaction counts. So how many requests are going to each of our origin regions?
So you clearly noticed something was going wrong, but obviously you want to dig deeper at that point. How did you do that?
Yeah, so the first thing we want to figure out is why are we seeing so many more transactions coming to our origin? This is scary. So did we just push a change to our CDN? Was it an application change? And is this traffic even real end user traffic, or is it some malicious attack? So leveraging New Relic APM, we were able to determine that yes, this traffic was real end users, and the increase in traffic correlated to the Notre Dame event, and the articles related to that. So from there, we dug further in, and we figured out that our HPA limit was actually limiting us from being able to scale out further and handle the load that we needed to manage to meet our demands for our users. So from there, we continued to, we adjusted the HPA, and then we continued to monitor our overall cluster health, as well as the health of our dependencies to ensure that the scale we were operating didn't have an impact on anything else within the cluster.
Yeah. So I like to see, again, the power of combining application data, APM data, bringing it in context with the Kubernetes cluster environment, and moving on from there. Those are great insights. Are there some lessons learned, with your experience of running Kubernetes at scale that you can share with the audience?
Yeah, absolutely. So throughout our journey on Kubernetes, we've had a lot of lessons learned or best practices we've discovered along the way. And 3 things I'd like to leave with you all today. So the first one is set, understand, and monitor your Kubernetes limits. So as you heard from our story, we actually did set a maximum limit on our HPA. And the reason why we set that is because we base it off of previous breaking news events. So we thought this was a good threshold, and if we go above that, we want to know why are we scaling up so many pods. But what we didn't do was setting alerting or monitoring around that. So that did provide some delay in the initial analysis of what was going wrong.
So it's not just we're setting an alert, we're done.
Yeah, so that's a really good start. But we have to understand those configurations are not static. So we're always driving to bring more users, more traffic to our products. We're deploying new features, and maybe even bringing more partners onto our clusters with us. So we have to, what may have worked this quarter or last year may not be meeting your expectations next quarter, 2 quarters down the road.
So there are a lot of changes, but how do you make it manageable then?
Yeah, so to start to understand and what those expectations are, you have to formally define them. So set your SLOs at a cluster level, at a namespace level, and at a service level. So what should my DNS latency be within the cluster? Or how many resources should I be expected to allocate to a certain service? Once you have these expectations defined, then you can start to monitor and review them at a regular cadence.
Makes sense. I really like how you're taking a very much data-driven approach here. I mean, the company obviously has goals. You're setting goals for your teams. But you're not just sticking with the goals. You're clearly defining, hey, this is how we're going to track against them. And I think this is very relevant for a lot of our customers here today in the audience, and great insights. What if people want to learn more about engineering at USA Today?
Yeah, so we have an engineering blog out there on Medium. It's medium.com/USA-today-network. So give us a follow.
Very cool. Thanks for those great insights. If anyone wants to get the source code of the game we used earlier, if you want to learn how to deploy this in EKS, please have a look at my GitHub. Kyle, thank you very much for joining us on stage today, and hope to see you again soon.
All right, thanks.